Hello students, now this is the last lecture in unit number 3 vector differentiation. Today we will complete our unit number 3 vector differentiation. So let's see our next result. Our next result is prove that nabla square f of r is equal to f double dash r plus 2 upon r f dash r, and this question is asked in 2019's paper in 3 marks. So here f double dash r denote the second order derivative of function f of r, and f dash r denote the first order derivative of function f of r. As we know, f of r is any function of r and r is a function of x, y, z. So proof is very easy. Here we start our proof with the LHS side and we obtain the RHS side. As you know, nabla square denote the Laplace operator. So here we just apply the formula of the Laplace operator and we just give the simplification and we get the answer. So let's see solution. So here we start our proof with the LHS side. So in LHS we have given nabla square f of r. So here we apply the formula of the Laplace operator. As we know, when phi is any scalar function, then we write the Laplace equation is del square phi upon del x square plus del square phi by del y square plus del square phi by del z square. So in this example we have given as a phi by f of r. અહીંયા આપણને જે phi ની જગ્યાએ ફંક્શન આપેલ છે f of r આપેલું છે, તો એના માટે આપણી જે લાપ્લાસ ઇક્વેશન આ રીતે લખાશે del square upon del x square f of r plus del square upon del y square f of r plus del square upon del y square f of r. Now this step is said to be equation number 1. Now to find value of del square upon del x square f of r, del square upon del y square f of r, del square upon del y square f of r. હવે મિત્રો આપણે આજે દરેક ટર્મ છે એની સેપરેટલી વેલ્યુ ફાઇન્ડ કરીશું. આફ્ટર ધેટ વી સબસ્ટિટ્યુટ ઓલ ધીસ વેલ્યુ ઇન ઇક્વેશન નંબર 1. સો ફર્સ્ટ ઓફ ઓલ વી ફાઇન્ડ del square upon del x square f of r. So first of all we want first order derivative means del upon del x. તો પહેલા આપણે જે ફંક્શન f of r છે એનું ફર્સ્ટ ઓર્ડર ડેરિવેટિવ મેળવીશું. So let's see obtain now del upon del x, our function is f of r. So here we obtain the first order derivative of our function f of r. So here we doing partial derivative of our function f of r with respect to x. That means મિત્રો આપણું f of r ફંક્શન છે એનું ફર્સ્ટ ઓર્ડર ડેરિવેટિવ ડિનોટ થશે f dash r અને બાજુમાં r નું થશે del r by del x as we know. So this is the first order derivative of our function f of r, but we want the second order derivative. So again here we doing partial derivative with respect to x. So write as the del square upon del x square f of r. હવે મિત્રો અહીંયા પાર્શિયલ ડેરિવેટિવનો આપણો જે મલ્ટિપ્લિકેશનનો નિયમ છે લાગુ પડશે, કારણ કે બંને ફંક્શન કેવા છે. હિયર f dash r and del r by del x both are the function of the x. So here we apply the multiplication rule. So f dash r as it is, f dash r ને આપણે as it is રાખ્યા છે. del r by del x નું with respect to x કરી દઈએ તો પાછું લખાશે del square r upon del x square. મિત્રો આ જે છે ફંક્શન r નું with respect to x ફર્સ્ટ ઓર્ડર ડેરિવેટિવ છે. અગેન આપણે with respect to x કરીએ તો સેકન્ડ ઓર્ડર ડેરિવેટિવ થશે, તો એને લખાશે del square r upon del x square plus del r upon del x as it is. હવે મિત્રો f dash r નું કરીશું તો f dash r નું થશે f double dash r. So second order derivative of f dash r is the f double dash r અને બાજુમાં r નું થશે del r by del x as we know. Now we just simplify this. So value of del square upon del x square f of r is equal to f dash r del square r upon del x square it is plus now see del r upon del x into del r upon del x. That means in 2 times in multiplication. So here we write in square form del r upon del x whole square into f double dash r. મિત્રો આ del r upon del x 2 times છે તો લખાશે del r upon del x whole square. So this is the value of del square upon del x square f of r. So here we not to find separately with respect to y and with respect to z. Here you can write directly similarly. So here we write as similarly here we write value for del square upon del y સ્ક્વેર એફ ઓફ આર. તો મિત્રો જે રીતે આપણે વિથ રિસ્પેક્ટ ટુ એક્સ મેળવ્યું હતું એમાં જ્યાં એક્સ હશે અહીંયા રિપ્લેસ થઈ જશે વાય. સો હિયર વી રાઇટ એઝ ધી એફ ડેશ આર del સ્ક્વેર આર અપોન del y સ્ક્વેર પ્લસ del r upon del y whole square into f double dash r. Similarly we write for z del square upon del z square to f of r is equal to f dash r into del square r upon del z square plus del r upon del z whole square into f double dash r. Now we substitute these three values in equation 1. So here write as from equation 1. Now from equation number 1, substitute the value. So LHS is equal to, our first value is del square upon del x square f of r is this. So write down this f dash r into del square r upon del x square plus del r upon del x whole square into f double dash r plus second value is f dash r del square r upon del y square plus del r upon del y whole square f double dash r plus f dash r del square r upon del z square plus del r by del z whole square f double dash r. Now this is called the equation number 2. Why here we say this step equation 2? Because we have not a value of del square r upon del x square, del square r upon del y square, del square r upon del z square. So first of all here we find this value del square r upon del x square, del square r upon del y square and del square r upon del z square. મિત્રો આપણી પાસે del r upon del x ની વેલ્યુ છે as we know del r by del x is nothing but the x by y, del r upon del y is nothing but the y by r and value of del r by del z is the z by r. પણ આપણી પાસે del square r upon del x square ની વેલ્યુ છે નહીં. So first of all here we find these three value. After that we substitute this value in equation number 2. So here we write as now. So here we write as we have, as we know value of del r upon del x, as we know we already obtained del r by del x is the x by r. તો આપણી આગળ ફર્સ્ટ ઓર્ડર ડેરિવેટિવ તો છે પણ આપણે કયું મેળવવાનું છે del square r upon del x square. So we want this second order derivative. So here we doing this term del r by del x with respect to x again. So here we get the second order derivative, write as the del square r upon del x square. તો મિત્રો x upon r છે તો અગેન r છે આપણું x y z નું ફંક્શન છે. સો અગેન હિયર વી એપ્લાય અવર ડિવિઝન રૂલ્સ. સો r એઝ ઇટ ઇઝ x નું થશે 1 માઇનસ x એઝ ઇટ ઇઝ r નું થશે del r by del x upon whole square upon denominator square over r square, r is the r square. Now we substitute the value as we know del r by del x is the x by r. So here we write as the r minus x, value of del r by del x is x by r upon r square. Now simplify this. So r minus, so here take r as an LCM, so r square minus x square upon r cube. મિત્રો 1 upon r છે ને આપણે LCM લીધો છે મીન્સ આ જે r છે એ r સાથે મલ્ટીપ્લાય થશે મીન્સ r સ્ક્વેર અને x ઇન્ટુ x સ્ક્વેર અને r ક્યાં આવી જશે છેદમાં, ધેટ મીન્સ થઈ જશે r ક્યુબ. સો ધીસ ધ વેલ્યુ ઓફ del square r upon del x square. Similarly we write for del square r upon del y square. So here we write as the similarly value of del square r upon del y square is equal to, we write as the r square. મિત્રો જ્યાં x square જ્યાં થઈ જશે y square upon r cube and value of del square r upon del z square is r square minus z square upon r cube. Now before erase this portion, here we recall all these things first of all, after that we erase this portion. So our proof is to prove nebula square f of r is equal to f double dash r plus 2 upon r f dash r. So here we start our proof with the LHS side. In LHS side we have given nebula square f of r. So that means here we apply our Laplace formula. So Laplace formula says that del square upon del x square f of r plus del square y upon del y square f of r plus del square upon del y z square into f of r. So this is called the equation number 1. Now we find the value of del square upon del x square f of r. તો એના માટે આપણે આગળ પહેલા ફર્સ્ટ ઓર્ડર ડેરિવેટિવ હોવું જોઈએ. સો ફર્સ્ટ ઓફ ઓલ વી ફાઇન્ડ ધ ફર્સ્ટ ઓર્ડર ડેરિવેટિવ ઓફ અવર ફંક્શન f of r. That means del upon del x f of r is nothing but the f of r નું ડેરિવેટિવ થશે f dash r અને એની બાજુમાં r નું થશે del r by del x. So this is the first order derivative of f of r. Now we find its second order derivative. So here we apply multiplication rule. F dash r as it is del r upon del x નું થશે del square r upon del x square plus del r upon del x as it is f dash r નું થશે f double dash r અને એની બાજુમાં થશે r નું del r by del x. So this is the value of del square upon del x square f of r. So here del r upon del x into del r upon del x square write in the form del r upon del x whole square. Similarly we write value for del square upon del y square f of r and del square upon del z square f of r. Now substitute these three value in equation 1. So here we write is the from equation 1. Here we just substitute the value. એને આપણે કીધું equation number 2. હવે મિત્રો આપણી પાસે del square r upon del x square ની વેલ્યુ છે નહીં, but we have a value of del r by del x, del r by del y and del r by del z. So using these three value we find the value of del square r upon del x square, del square r upon del y square and del square r by del z square. So we have del r upon del x is the x by r. So here we doing partial derivative of this term del r by del x with respect to x. So r as it is x નું થશે 1 minus x as it is r નું થશે del r by del x અને છેદનો square means r square. Now we substitute the value of del r by del x. So del r by del x is nothing but the x by r. Now we take r as an LCM. So r multiply with this r. So we write as the r square x into x square upon r cube. Similarly we write the value for del square r upon del y square and del square r upon del z square. Now substitute these three value in equation number 2. So here we write as from equation 2. Now we substitute these three value in equation number 2. So LHS is equal to f dash r as it is. Now substitute the value of del square r upon del x square. So value of del square r upon del x square is this r square minus x square upon r cube. So here we write as the r square minus x square upon r cube plus, as we know, value of del r by del x is the x by r. So here write as the x upon r whole square plus f dash r as it is into value of del square r upon del y square is this r square minus y square upon r cube. So here write as the r square minus y square upon r cube plus y by r square. As we know, value of del r by del y is the y by r plus, similarly we write value for last term f dash r, and here I mean the second order derivative in multiplication f double dash r plus f dash r as it is del square upon del z square is r square minus z square upon r cube plus z by r square into f double dash r. Now observe our RHS portion. We want the f double dash r plus 2 upon r f dash r. So first of all here we collect all the terms of the f dash r. મિત્રો આપણે RHSમાં જોઈએ છે f double dash r, તો એ આપણને ક્યાંથી મળશે? ના ઓબ્ઝર્વ ધીસ ટર્મ. આ જે ત્રણ ટર્મ્સ છે એમાંથી f double dash r આપણે કોમન લેશું. સો ફર્સ્ટ ઓફ ઓલ હિયર વી રાઇટ ધીસ પોર્શન ફર્સ્ટ ઓફ ઓલ આ જે હાઇલાઇટ કરેલ ટર્મ છે એમાંથી આપણે એફ ડબલ ડેશ આરને કોમન લઈએ છીએ. સો ટેક આઉટસાઇડ એફ ડબલ ડેશ આર. રિમેનિંગ ટર્મ ઇઝ મિત્રો અહીંથી કોણ વધશે? x upon r whole square can be written as the x square upon r square. Similarly, y square upon r square and z square upon r square. F double dash r, F double dash r, F double dash r take outside. So remain here x square upon r square plus y square upon r square plus z square upon r square. મિત્રો આ ત્રણ ટર્મ્સમાંથી આપણે એફ ડબલ ડેશ આર કોમન લીધા છે તો વધશે અહીંથી એક્સ સ્ક્વેર અપોન આર સ્ક્વેર પ્લસ વાય સ્ક્વેર અપોન આર સ્ક્વેર પ્લસ ઝેડ સ્ક્વેર અપોન આર સ્ક્વેર. Now we want the f double dash, sorry, f dash r. So now take f dash r common in this remaining three terms. Take f dash r outside. મિત્રો આ ત્રણ ટર્મ્સમાંથી આપણે f dash r કોમન કાઢી લઈએ તો ફર્સ્ટ ટર્મમાંથી વધશે r square minus x square upon r cube plus r square minus y square upon r cube plus r square minus z square upon r cube. Now just simplify this. f double dash r as it is. મિત્રો દરેક ટર્મ્સમાંથી છેદ કોમન છે 1 upon r square ટેક આઉટસાઇડ 1 upon r square. અંશમાં વધશે x square plus y square plus z square. Now take 1 upon r square outside in these three terms. So f double dash r upon r square remaining the x square plus y square plus z square. Plus similarly here f dash r take 1 upon r cube common. So here remain the r square minus x square plus r square minus y square plus r square minus z square means r square plus r square plus r square. That means 3 times r square. Now remaining term is the minus x square minus y square minus z square. Take minus outside, so remaining the x square plus y square plus z square. મિત્રો આ જે પોર્શન છે એમાંથી 1 upon r ક્યુબ આપણે કોમન લીધા છે. r ક્યુબ સોરી r સ્ક્વેર પ્લસ r સ્ક્વેર પ્લસ r સ્ક્વેર થઈ જશે 3r સ્ક્વેર. બાકીની ટર્મ્સ હતી આપણી માઇનસ એક્સ સ્ક્વેર માઇનસ વાય સ્ક્વેર માઇનસ z સ્ક્વેર. ટેક માઇનસ આઉટસાઇડ, સો રિમેનિંગ ધી x સ્ક્વેર પ્લસ y સ્ક્વેર પ્લસ z સ્ક્વેર. નાઉ સિમ્પ્લિફાય ધીસ. f double dash r upon r square. As we know, x square plus y square plus z square is nothing but the r square. Plus, as we know, value of r is the under root x square plus y square plus z square. So, square of, as we know, r is equal to under root x square plus y square plus z square. So, r square is nothing but the x square plus y square plus z square. So here we substitute the value x square plus y square plus z square is nothing but the r square. Similarly here f dash r as it is upon r cube. Now see 3r square as it is minus x square plus y square z square is nothing but the r square. So LHS is equal to, so here r square cut, remaining the f double dash r plus f dash r upon r cube. 3r square minus r square remain the 2r square. So f double dash r plus here r square upon r cube cut, so remain the 2 by r into f dash r. R square upon r cube, so remaining the 2 upon r into f dash r, and this is nothing but our RHS side. Hence proved. So proof is just long but it's very easy. મિત્રો ખાલી કેલ્ક્યુલેશન છે જરાક લોંગ છે, બાકી પ્રૂફ સાવ એકદમ ઇઝી છે. ઇફ યુ નો ધી ફોર્મ્યુલા ઓફ ધી લાપ્લાસ ઓપરેટર then you can easily prove this result. So doing practice you can easily prove this result. Now we discuss the second one. Now this is the last result in unit number 3 vector differentiation, and this question is asked in 2018's paper in 5 marks. So result is say that prove that 1 upon r satisfies the Laplace equation and also prove that curl of gradient r raised to n is equal to 0 vector. So this question combine the two questions. So first of all here we prove 1 upon r satisfy the Laplace equation. As you know, what is the meaning of the Laplace equation satisfy means to prove nebula square phi is equal to 0. That means phi satisfy the Laplace equation. But in this case, our function is the 1 upon r. So that means to prove nebula square 1 upon r is equal to 0. And next result to prove that curl of gradient r raised to n is equal to 0 vector. तो मित्रों आ रिजल्ट प्रूफ करवा माटे आपणी पासे पहला तो ग्रेडियंट ऑफ r रेज़ टू n होवा જોઈએ. सो आ रिजल्ट प्रूफ करता पहला આપણે ગ્રેડિયન્ટ ઓફ r રેઝ ટુ n મેળવીશું અને એનો હું ફાઇન્ડ કરવાનો છે કર્લ and to prove is equal to 0 vector. So first of all here we prove 1 upon r satisfy the Laplace equation. Let's see solution. So here we write is first to prove prove 1 upon r satisfied Laplace equation. That means to prove nebula square 1 upon r is equal to 0. So આપણે પ્રૂફ શું કરવાનું રહેશે nebula square 1 upon r is equal to 0. So here we start our proof with the LHS side and we obtain the RHS side. So in LHS is nebula square 1 upon r. So here we apply the Laplace formula. Nebula means del square upon del x square 1 upon r plus del square upon del y square 1 upon r plus del square upon del z square into 1 upon r. So this is called the equation number 1. Why we say equation 1? Because first of all here we find the value of del square upon del x square 1 upon r. Next we find the value of del square upon del y square 1 upon r and del square upon del z square 1 upon r. So first of all we find del square upon del x square. So first of all we find the first order derivative del upon del x of function 1 upon r. So derivative of 1 upon r is the minus 1 upon r square and બાજુમાં r નું થશે del r by del x. Now substitute the value of del r by del x. So minus 1 upon r square. Value of del r by del x is the x by r. So answer is the minus x upon r cube. So this is the first order derivative of 1 upon r. તો મિત્રો આપણે ફર્સ્ટ ઓર્ડર ડેરિવેટિવ મળ્યું છે આપણને del upon del x 1 upon r is minus x upon r cube. Now we find the second order derivative. So here we write is the del square upon del x square 1 upon r. So here we apply our division rule. Minus as it is. મિત્રો જે માઇનસ છે ને આપણે બહાર રાખી છે. Now we apply our division rule for x upon r cube. So r cube as it is x નું થશે 1 માઇનસ x as it is r cube નું થશે 3r સ્ક્વેર અને બાજુમાં r નું થશે del r by del x upon છેદનો સ્ક્વેર તો r cube નો સ્ક્વેર થશે r raised to 6. Now we just simplify this. So value of del square upon del x square 1 upon r is equal to minus as it is 1 upon r cube 1 upon r raised to 6. Now r cube minus મિત્રો del r upon del x ની વેલ્યુ આવશે x by r. તો અહીંથી એક એક r કટ થઈ જશે. Or we can also write down so we better understand. So here we write as the 3x r square અને value of del r by del x થશે x by r. Here we substitute the value of del r by del x is the x by r. Now we write as the minus 1 upon r raised to 6 r cube minus x by r. So here 1 r is the cut. So remain the 3r into x square. So this is the value of del square upon del x square 1 upon r. Now we write for similarly. Or we can also say, now see r cube and r. So take 1 r outside. So here remain minus 1 upon r raised to 5. Here we write as the r square minus 3x square. મિત્રો આમાંથી જે આર એક કોમન નીકળી શકે છે તો આપણે આરને કોમન લીધા છે. સો હિયર રિમેન ધી આર સ્ક્વેર માઇનસ 3x સ્ક્વેર, અને જે આપણે આર કોમન લીધા છે અહીંયા કટ થઈ જશે. સો રિમેન -1/r⁵ આર સ્ક્વેર માઇનસ 3x સ્ક્વેર. સો ધીસ ધ વેલ્યુ ઓફ del square upon del x square 1/r. Similarly here we write del square upon del y square 1/r can be written as the -1/r⁵. વેલ્યુ મળશે મિત્રો આર સ્ક્વેર માઇનસ 3y સ્ક્વેર એન્ડ del square upon del z square 1/r is equal to -1/r⁵ r square minus 3z square. Now substitute these three values in equation 1. So here we write as from equation 1. From equation 1, LHS is equal to, first we write value of del square upon del x square 1/r. Here we get the -1/r⁵ r square minus 3x square plus value of del square upon del y square -1/r square minus 3y square minus value of del square upon del z square is -1/r square, sorry, r⁵. Here it is the r⁵ r square minus 3z square. Now see, -1/r⁵ take outside in these three terms. So here it is the -1/r⁵ take outside. So remaining is here plus r square plus r square plus r square. So here it is the 3 times r square and -3x square minus 3y square minus 3z square. So minus take outside, remaining the x square plus y square plus z square. મિત્રો દરેક ટર્મ્સમાંથી આપણે -1/r⁵ કોમન લીધા છે તો અહીંથી વધશે r સ્ક્વેર પ્લસ r સ્ક્વેર પ્લસ r સ્ક્વેર બીકોઝ વી ઓલરેડી ટેક માઇનસ આઉટસાઇડ. સો પ્લસ r સ્ક્વેર પ્લસ r સ્ક્વેર પ્લસ r સ્ક્વેર દેટ મીન્સ 3r સ્ક્વેર. હવે જે માઇનસ ટર્મ છે -3x સ્ક્વેર માઇનસ 3y સ્ક્વેર માઇનસ 3z સ્ક્વેર ટેક -3 આઉટસાઇડ. સો રિમેનિંગ ધી x સ્ક્વેર પ્લસ y સ્ક્વેર પ્લસ z સ્ક્વેર. એઝ યુ નો x સ્ક્વેર પ્લસ y સ્ક્વેર z સ્ક્વેર ઇઝ નથિંગ બટ ધી r સ્ક્વેર. સો હિયર વી રાઇટ એઝ LHS is equal to -1/r⁵ (3r square minus x square plus y square plus z square is nothing but the r square minus 3r square. 3r square minus 3r square answer is the 0. તો મિત્રો આપણે પ્રૂફ શું કર્યું? del square upon del x square 1/r plus del square upon del y square 1/r plus del square upon del z square 1/r is equal to 0. That means our function 1/r satisfies the Laplace equation is equal to RHS. So here it is the 1/r satisfied Laplace equation, hence proved. તો મિત્રો 1/r છે એ લાપ્લાસ ઇક્વેશન સેટિસ્ફાય કરે છે બીકોઝ વી પ્રૂવડ નેબલા સ્ક્વેર 1/r is equal to 0. So this is the solution of our first example. Now to prove curl of gradient r⁵n is equal to 0 vector. So let's see solution of second one. So here we write as now to prove curl of gradient r⁵n is equal to 0 vector. So first of all here we find the gradient of r⁵n. So here we write as gradient of r⁵n. So here we apply the formula of the gradient, that means del upon del x r⁵n I cap plus del upon del y r raised to n j cap plus del upon del z r raised to n into k cap. મિત્રો આપણું ફંક્શન છે r raised to n. So here we apply formula of the gradient as we know del upon del x r raised to n I cap plus del upon del y r raised to n j cap plus del upon del z r raised to n into k cap. Now we doing partial derivative of r raised to n with respect to x. તો r raised to n નું થશે n r raised to n minus 1. મિત્રો આ પૂરું થઈ જશે ને બાજુમાં આવશે del r by del x into I cap. Similarly with respect to y and with respect to z કરીશું. So n r raised to n minus 1 del r by del y into j cap plus n r raised to n minus 1 del r by del z into k cap. r raised to નું થશે n r raised to n minus 1 અને બાજુમાં થશે del r by del x I cap plus n r raised to n minus 1 into del r by del y j cap plus n into r raised to n minus 1 into del r upon del z into k cap. We substitute the value of del r by del x. As we know, value of del r by del x is the n r n minus 1. Value of del r by del x is the x by r. So x by r into I cap plus n minus 1. Value of del r by del y is the y by r into j cap plus n r raised to n minus 1. Value of del r by del z is the z by r into k cap. Now simplify this. So n મિત્રો અહીંથી વધશે nx r raised to n minus 1 અને છેદમાં r છે તો થઈ જશે n into n r raised to n minus 2 into x into I cap. મિત્રો એક એક r કટ થઈ જશે તો r raised to n minus 1 ના થઈ જશે r raised to n minus 2. So remaining here x into n r raised to n minus 2. Similarly n into r raised to n minus 2 into y j cap plus n r raised to n minus 2 into z into k cap. So this is the gradient of r raised to n. Now we start our result with the LHS side and we obtain the RHS side. So first of all here we write our f1 term is n r raised to n minus 2x. Our f2 term is n r raised to n minus 2 into y. And our f3 term is n r raised to n minus 2 into z. Now we find the curl. That means here we start with the LHS side. So LHS is equal to curl of gradient r raised to n. So as you know, what is the formula? Ijk del by del x del by del y del by del z. Here write the curl કેનો ફાઇન્ડ કરવાનો છે મિત્રો gradient r raised to n. આપણે gradient મળ્યો છે આ છે તો એમાં f1 ટર્મ છે આપણી આ. So here we write is the nx r raised to n minus 2. Next f2 term is the ny r raised to n minus 2. You can also write n r raised to n minus 2 into y. And our f3 term is the n into z r raised to n minus 2. Now we just simplify this. So del upon del y into nz r raised to n minus 2 minus del upon del z into ny r raised to n minus 2 into I cap. Now minus del upon del x into nz r raised to n minus 2 minus del upon del z into nx r raised to n minus 2 into j cap plus del upon del x ny r raised to n minus 2 minus del upon del y minus del upon del y into nx r raised to n minus 2 into k cap. મિત્રો અહીં જે આપણો ડિટરમિનન્ટ મળ્યો છે એને આપણે સિમ્પ્લિફાઈ કરેલ છે. નાવ વી ડુઈંગ derivative partial derivative this term nz r raised to n minus 2 with respect to y. So let's see here. મિત્રો આપણી જે ટર્મ છે NZ r⁻n-2 એનું પાર્શિયલ ડેરિવેટિવ વિથ રિસ્પેક્ટ ટુ y કરી છે ત્યારે NZ આપણા કોન્સ્ટન્ટ કાઉન્ટ થશે અને r⁻n-2 નું ડેરિવેટિવ થશે. વાય બિકોઝ r ઇઝ અ ફંક્શન ઓફ x y z. સો r ઇઝ ધ વેરિયેબલ ફંક્શન. તો r⁻n-2 નું થશે NZ એઝ ઇટ ઇઝ n-2 ઇન્ટુ r⁻n-3 અને બાજુમાં r નું થશે ∂r/∂y. લેટ્સ સી હિયર. સો હિયર we write as the LHS is equal to, here we are doing partial derivative with respect to y. So NZ as a constant count, NZ as it is r⁻n-2 થશે, n-2 આગળ આવી જશે, n-2 આગળ આવી જશે, એક ઘાત વચ્ચે મીન્સ r⁻n-3. હજી મિત્રો આ પૂરું થઈ જશે નહીં, આપણે આરનું ડેરિવેટિવ વિથ રિસ્પેક્ટ ટુ વાય કરી છે તો બાજુમાં લખાશે ∂r/∂y. Similarly, here we are doing for remaining terms minus. Here we are doing partial derivative of this term ny r⁻n-2 with respect to z. So ny as a constant count. So ny as it is r⁻n-2 થશે n-2 r⁻n-3 બાજુમાં r નું with respect to z થશે ∂r/∂z into I cap. So this is the first derivative of our first term. Now minus. Similarly, here we are doing for remaining terms. Now in second term, NZ r⁻n-2 with respect to x કરી તો NZ count constant count થશે NZ as it is into n-2 r⁻n-3 with respect to x કરી છે તો બાજુમાં લખાશે ∂r/∂x minus nx r⁻n-2 with respect to z કરી છે તો nx as it is n-2 r⁻n-3 with respect to z કરી છે તો લખાશે ∂r/∂z into j cap plus here we are doing partial derivative of this term with respect to x. So ny into n-2 r⁻n-3 into, here we are doing with respect to x, so write as the ∂r/∂x minus, here we are doing with respect to y, so nx count as the constant nx n-2 બાજુમાં લખાશે ∂r/∂y because we are doing with respect to y into j cap. Here remaining the n-3 r⁻n-3 into ∂r/∂y into k cap. So this is the solution. This is the solution of this step. Now we just substitute the value of ∂r/∂y. Here we substitute the ∂r/∂z, ∂r/∂x. So here we write as now we just substitute the value NZ n-2 as it is r⁻n-3. Now we substitute the value of ∂r/∂y. ∂r/∂y is the y/r minus ny into n-2 r⁻n-3. We substitute the value of ∂r/∂z is the z/r into I cap minus in second step, in second term, NZ n-2 as it is NZ n-2 r⁻n-3 it is. We substitute the value of ∂r/∂x is the x/r minus nx n-2 r⁻n-3. Here we substitute the value of ∂r/∂z is the z/r into j cap plus in last term ny n-2 r⁻n-3. Value of ∂r/∂x is the x/r minus nx n-2 r⁻n-3 into value of ∂r/∂y is the y/r into k cap. Now just simplify, you get the answer. Now see, here r raised to n minus 3 upon r, so here 1r is the cut, so remaining is the nzy. મિત્રો અહીં વધશે nzy n minus 2 r raised to n minus 3. Here 1r is the cut, so here remain the r raised to n minus 4. 1r is cut, nzy n minus 2 r raised to n minus 4. Similarly here 1r is the cut, remaining the nyz n minus 2 r raised to n minus 4 into I cap. Minus same in second term, here 1r is the cut, remaining the nzx n minus 2 r raised to n minus 4 minus here r is the cut, remaining the nxz n minus 2 r raised to n minus 4 into j cap plus in this term r is the cut, nyx n minus 2 r raised to n minus 4 minus here r is the cut, remaining the nxy n minus 2 r raised to n minus 4 into k cap. Now see, nzy n minus 2 r raised to n minus 4 minus nzy or nyz n minus 2 r raised to n minus 4 means બંને ટર્મ કેવી છે સરખી થઈ જશે, that means 0 I cap minus similarly nzx n minus 2 r raised to n minus 4 minus nxz n minus 2 r raised to n minus 4 both term are the same, so minus 0 j cap plus nyx n minus 2 r raised to n minus 4 minus nxy or nyx n minus 2 r raised to n minus 4, so again is the 0 k cap. So there is nothing but the 0 vector and there is nothing but the RHS. To prove curl of gradient r raised to n is equal to 0 vector, so here we proved is equal to 0 vector and this is nothing but our RHS side. So this is the proof of our last example, unit number 3 vector differentiation. So here your unit 3 is over. In next lecture we will meet with the new units. Thanks for watching this video. Thank you. Have a good all of you.